Look up at the night sky on a clear evening and you might notice a faint, hazy glow sitting quietly beyond the stars. That glow is not just light, it is the Andromeda Galaxy, a vast cosmic structure drifting in the darkness, silently pulling at human imagination. At first glance, it feels close, almost reachable, as if a journey toward it is only a matter of future technology. The mind instantly fills the gap between here and there with ideas of spacecraft, advanced engines, and civilizations capable of crossing the stars. And in that moment, a powerful question emerges. If nothing in the universe can travel faster than light, what would happen if we could reach that ultimate speed? Would Andromeda finally become a reachable destination? For the human mind, the speed of light feels like the final escape from every limitation. It represents the absolute limit of motion, the fastest possible way to move through reality. From childhood, we are conditioned to believe that if something can move fast enough, distance eventually loses meaning. So naturally, we imagine that traveling at light speed would turn the entire universe into something accessible, where galaxies are no longer unreachable points but future destinations waiting to be explored. Andromeda, in that imagination, becomes just a very long trip instead of an impossible one. But modern physics dismantles this comforting illusion. The problem is not simply that reaching the speed of light is impossible for anything with mass. The deeper truth is far more unsettling. Even light itself does not behave in a way that makes the universe simple or predictable on cosmic scales. The structure of reality is not built around human intuition, and what feels logical at small scales completely breaks down when applied to galaxies. The biggest misunderstanding comes from how we picture space. Before Einstein, space was imagined as a fixed, silent stage, where everything simply moved from one point to another. In that model, if a ship were fast enough, any destination could eventually be reached. Distance was just a matter of time and effort. But relativity replaced that idea with something far more complex and strange. Space is not static. It stretches, bends, and evolves. This single realization changes everything. The universe is not a motionless backdrop, it is an active, expanding structure. Galaxies are not simply moving through space like ships in water. Instead, space itself is expanding between them. This means that distances in the cosmos are not fixed values. They are dynamic, constantly changing while you try to measure or cross them. That is why some galaxies appear to move away from us faster than light itself. At first, this seems to break the laws of physics, but it does not. The galaxies are not traveling through space at impossible speeds. Instead, the space between us and them is expanding. Relativity restricts how fast objects can move within space, but it does not limit how space itself can grow. This difference is crucial. It completely reshapes our understanding of the universe and our place within it. The cosmos is not a simple arena where distance can always be conquered. It is a living geometry, constantly reshaping itself while we try to observe it. And within this expanding structure lies something even more unsettling, a cosmic horizon, a boundary beyond which information can never reach us. Not because signals are too weak or technology is insufficient, but because the expansion of space itself can outrun light. There are regions of the universe that are permanently unreachable, not just today, but forever. This means the universe is not fully accessible. It contains hidden regions that no future civilization will ever touch or observe directly. Andromeda, however, is not one of those unreachable regions. In fact, it is slowly moving toward the Milky Way due to gravitational attraction. But it still serves as a powerful example because it reveals a deeper truth. Even the fastest possible motion in the universe is not enough to guarantee access to everything. The universe does not simply limit speed, it limits possibility. And that realization is where our journey truly begins. To understand why distance becomes so strange on cosmic scales, we need to confront one of the most difficult ideas in modern physics. Time is not absolute. It does not flow the same way for everyone everywhere. Instead, it is deeply connected to motion and gravity, changing depending on how fast you move and where you are in the universe. At everyday speeds, this feels meaningless. A walking person, a flying airplane, or even a fast rocket experiences time almost identically to someone standing still on Earth. Because of this, we naturally assume time is universal. But this assumption collapses completely when we approach extreme velocities. Imagine a spacecraft traveling toward Andromeda at a speed close to that of light. From Earth's perspective, the journey might appear to take 2.5 million years, because that is how long light itself takes to cross the distance. But for the people inside the ship, something very different happens. Time begins to slow down. This effect is not a theory, it has been measured and confirmed. Particles called muons, which normally decay extremely quickly, survive longer when they move at near light speeds. Their internal processes slow down relative to outside observers. This shows that time is not fixed. It stretches depending on motion. For a near-light-speed traveler, the journey to Andromeda could feel surprisingly short. It might take only a few years of personal experience, even though millions of years pass outside the ship. Inside the spacecraft, clocks tick slowly, biological aging reduces, and even the rhythm of thought changes relative to the outside universe. This creates a strange asymmetry. The traveler and the universe no longer share the same time. While the crew experiences a brief journey, entire civilizations on Earth could rise and disappear. Continents may shift, languages evolve beyond recognition, and the sun itself continues its slow transformation. By the time the ship arrives, the world it left behind would no longer exist in any recognizable form. This is where relativity becomes emotionally disturbing. The cost of extreme speed is not just energy or engineering, it is separation from history itself. The faster you move, the more you detach from the shared timeline of everything you know. In this sense, the traveler becomes a kind of temporal exile, not lost in space, but lost in time. And this disconnection grows deeper as speed increases. The outside universe continues its normal progression, while the traveler remains locked in a slowed experience. The result is a split reality where two versions of time exist simultaneously, both valid, both real, but no longer synchronized. Even the view from inside the ship becomes distorted. Light from stars ahead compresses and shifts in frequency. Space itself appears shortened in the direction of travel, as if the universe is physically folding toward the ship. Everything begins to feel compressed, accelerated, and alien compared to human experience. This reveals something profound. What we call normal time is only a local condition. It exists because we move slowly compared to the speed of light. If we moved faster, reality itself would feel different visually, physically, and psychologically. There is no single universal clock governing everything. Each observer carries their own version of time, shaped by motion and gravity. And once this truth is accepted, the idea of a simple journey through space becomes far more complex. Because traveling to Andromeda is no longer just about distance. It is about deciding which version of reality you will experience and what version you will leave behind forever. As we push deeper into this idea, the universe becomes even more unsettling. The expansion of space itself introduces a limit that even light cannot overcome. This is where our intuition begins to fail completely, because we tend to imagine space as something empty and stable. But in reality, space is dynamic. It grows, stretches, and evolves over time. This expansion was first revealed when astronomers noticed that light from distant galaxies was shifting toward the red end of the spectrum. This red shift showed that galaxies were moving away from us. But the deeper explanation was far more radical than simple motion. It was not that galaxies were flying through space like debris after an explosion. Instead, space itself was expanding everywhere at once. A useful way to imagine this is to think of dots on the surface of a balloon. As the balloon inflates, the dots move farther apart, not because they are walking away from each other, but because the surface itself is stretching. In the same way, galaxies are carried apart by expanding space. This means that distance is not a fixed measurement. It is constantly increasing in many parts of the universe without anything actually moving in the traditional sense. Now, this creates a deep problem for space travel. Even if a spacecraft could move at nearly the speed of light, it would still be traveling through a universe where the destination is drifting away due to expansion. In some cases, the expansion is so strong that it outpaces light itself. This leads to a disturbing conclusion. There are regions of the universe that are fundamentally unreachable. Not because they are too far in a static sense, but because space is expanding too quickly for any signal or ship to ever catch up. It is like running on a treadmill that constantly speeds up. No matter how fast you move, the finish line keeps slipping away. This introduces a paradox. According to relativity, nothing can travel through space faster than light. But space itself can expand in such a way that distant galaxies separate faster than light speed travel would allow. The rule applies to motion within space, not to space itself. This distinction is essential. It means the universe is not just vast, it is actively expanding its own boundaries faster than any traveler can hope to cross them. As a result, the observable universe becomes only a limited region of a much larger reality. Beyond it lie areas that we will never see, never reach, and never communicate with. They are not hidden by technology, they are hidden by the structure of space-time itself. Andromeda exists inside our local cosmic neighborhood, which is why it remains accessible in principle. Gravity holds nearby galaxies together strongly enough to resist expansion at small scales. But beyond these regions, expansion dominates completely, locking entire parts of the cosmos away forever. This creates a universe divided by invisible boundaries, not walls made of matter, but limits written into geometry itself. And once again, the deeper truth emerges. The universe is not designed around human ambition. It does not bend to our desire to explore. Instead, it follows rules that quietly determine what can and cannot ever be reached. And those rules are far more absolute than anything we experience on Earth. The deeper we go into relativistic space, the more we discover that distance is not the only thing being transformed, identity itself begins to change. When traveling at extreme speeds, not only does time slow down, but the relationship between the traveler and the rest of the universe begins to break apart in a profound way. A journey to a distant galaxy like Andromeda is often imagined as a long voyage through empty space. But relativity reveals something far more extreme. It is not just a trip across distance, but a separation across time itself. While a traveler experiences only a short duration inside their spacecraft, the universe outside continues to age normally. This creates a staggering imbalance. Imagine a crew leaving Earth with the intention of returning after reaching Andromeda. From their perspective, they might experience only a few years or decades of travel. But upon return, they would not find the world they left behind. They would find an entirely different civilization, or possibly none at all. Entire epochs of human history would unfold without them. Species could evolve, societies could vanish, and even the structure of Earth's environment could change beyond recognition. The familiar world becomes something distant and unreachable, not because of space, but because of time. This is where relativity becomes emotionally profound. The traveler does not simply move through space, they move out of sync with history itself. Every moment of acceleration increases the separation from the shared timeline of humanity. In this sense, the traveler becomes temporally disconnected from their origin. They are no longer part of the same unfolding story. They are observers moving through a different flow of time. This separation affects more than history. It affects experience. Human consciousness is built on continuity, memories, relationships, shared events. These depend on synchronized time. When that synchronization breaks, identity itself begins to feel fragmented. At extreme speeds, even perception changes. Light from the universe becomes distorted, compressed, and shifted. The sky no longer looks familiar. The direction of motion compresses the visual field, while the rear of the universe stretches out. Reality becomes warped in ways that are impossible to intuit from everyday life. What was once a stable and shared universe becomes a highly directional and relative experience. And this reveals something deeply important. Our everyday sense of time and space is not fundamental. It is a local approximation, shaped by slow movement and weak gravity. It feels universal only because we have never experienced conditions where it breaks down. But at cosmic speeds, it does break down. There is no single universal present moment. Instead, there are countless overlapping realities, each shaped by the motion of the observer. Two beings moving differently through space may disagree completely about what events are happening now. This destroys the idea of a shared cosmic present. And once that idea disappears, the universe becomes something far more complex than a simple stage. It becomes a network of relative experiences, each valid within its own frame, yet disconnected from others in fundamental ways. The journey to Andromeda, then, is not just a test of technology. It is a test of whether a civilization can survive the fragmentation of time itself. As we continue deeper into the structure of the cosmos, another realization emerges that changes everything we thought we knew about space. The vacuum is not empty. For centuries, humans imagined space as a silent, empty container where stars and galaxies simply existed. But modern physics reveals that this idea is incomplete. Space is not nothing, it is something. It has structure, energy, and dynamic behavior. It can stretch, curve, and influence everything embedded within it. This means the universe is not made of objects floating in emptiness, it is made of objects interacting within a living geometry. One of the strongest pieces of evidence for this comes from the observation of distant galaxies. When astronomers studied their light, they discovered a consistent redshift, meaning those galaxies were moving away from us. But the explanation was not that everything is flying apart from a central explosion. Instead, the entire fabric of space is expanding uniformly. This leads to a very counterintuitive reality. There is no central point of expansion. Every galaxy sees others moving away from it, because space itself is stretching everywhere at once. This can be visualized like points on an inflating balloon. As the balloon expands, every point moves away from every other point, not because the points are moving across the surface, but because the surface itself is growing. In cosmic terms, galaxies are carried apart by the expansion of space itself. Now consider what this means for travel. Even if a spacecraft could approach the speed of light, it would still be trying to cross a universe that is continuously changing shape. The destination is not fixed, it is drifting due to expansion. This introduces a fundamental limit. Some galaxies are so far away that they will never be reachable, even with unlimited patience. The space between us and them expands faster than light can compensate. This is not a failure of engineering, it is a property of reality. It also leads to a fascinating paradox. While nothing can move through space faster than light, Space itself can expand in such a way that distant regions separate faster than light-speed travel would allow. This is not a violation of physics, but a deeper layer of it. The universe is effectively self-expanding, creating boundaries that are not physical but geometric. These boundaries define what we can ever observe or influence. They form a cosmic horizon beyond which information cannot reach us. Even if those regions contain galaxies, stars, or possibly life, they remain permanently inaccessible. Andromeda lies within the reachable region of the universe because gravitational forces hold it close enough to resist the full effect of expansion. In a distant future, it will even collide with the Milky Way. But this is an exception that highlights the rule. Only nearby structures remain bound. Everything else drifts away. As expansion continues, the universe becomes increasingly isolated. Regions drift apart, communication becomes impossible, and the cosmos fragments into disconnected islands of matter. This leads to a haunting conclusion. The universe is not a single unified space. It is a collection of regions slowly losing contact with each other forever. And the force driving this separation is not an external push. It is the behavior of space itself. At the deepest level, everything we have explored leads to a single overwhelming realization. The universe is not built for traversal. It is built for separation. Every layer of physics, from relativity to cosmic expansion, reinforces the same truth. Distance is not just large, it is fundamentally protected by the structure of reality. Even if a civilization were to survive for millions or billions of years, developing unimaginable technologies, it would still face barriers that are not technological but absolute. The speed of light is not a challenge to overcome. It is a boundary woven into the fabric of space-time itself. The closer an object gets to that limit, the more the universe resists its motion, demanding infinite energy to go further. This creates a kind of cosmic confinement, not a prison built by walls, but a prison built by geometry. Every attempt to escape deeper into the universe is constrained by rules that cannot be negotiated or bypassed. Andromeda, despite its apparent closeness in the night sky, sits millions of light years away in a reality that refuses to compress under human desire. Even though gravity will eventually pull it into collision with the Milky Way, that event exists on timescales so vast that it feels almost unreal from a human perspective. Meanwhile, time itself becomes a dividing force. Relativity ensures that no universal now exists. Each observer carries their own timeline, and communication between distant regions becomes increasingly delayed until it effectively breaks the sense of shared existence. Civilizations separated by vast distances would not experience history together, they would experience it in fragments, disconnected and asynchronous. Even energy and matter do not behave in a stable, permanent way over cosmic timescales. Stars burn, collapse, and transform. Galaxies evolve. Entire structures shift slowly across millions of years, reshaping the night sky into something unrecognizable. The universe is not a static map, it is a continuously unfolding process. And at the heart of it all lies a final, unsettling idea. The vacuum itself is not passive. The so-called emptiness of space is filled with energy and activity, often described as dark energy. This invisible component appears to be driving the accelerated expansion of the universe, pushing galaxies apart faster over time. We do not fully understand it, yet it shapes the fate of everything that exists. So the cosmos is not simply expanding, it is accelerating its separation. When all of these ideas come together, a profound philosophical conclusion emerges. Human beings are capable of imagining the entire universe, of constructing mathematical models that describe its deepest behavior, and of mentally traveling across billions of light years. Yet physically, we remain confined to a tiny region of space-time, unable to cross even the nearest galactic boundaries in any practical sense. This is the central paradox of existence. The mind is infinite in imagination, but the body is finite in motion. We can understand the structure of the cosmos, but we cannot escape it. Andromeda becomes more than a galaxy, it becomes a symbol of this limitation. It is close enough to see, distant enough to never fully reach in the way intuition expects, and governed by laws that redefine what travel even means. So when we look at the night sky again, that faint glow is no longer just a destination. It is a reminder of the universe's deepest rule. Everything is connected by space, but separated by time and expansion. And if you want to explore more deep cosmic stories like this, subscribe and stay tuned because the universe still has far more secrets waiting to be uncovered.